Your support helps us bring you programs you love. Go to WyomingPBS.org, click on Support, and become a sustaining member or an annual member. It's easy and secure. Thank you.
These are still some of the biggest glaciers in the lower 48.
When you actually stand on a glacier, that's a lot of water sitting beneath you. There's plants and animals that need that water to survive.
We can't say what's going to happen to all the animals living in that forest, but it's certainly going to change.
We're trying to see how climate change is affecting the quality of the water.
This is a logistically highly intense, highly complex expedition. There's no question about it.
Rerun the Cheeseboro transect with both antennae.
What we were trying to do is find the volume of the glacier.
We'd like to create a new benchmark for the greater Yellowstone ecosystem.
A lot of people hear about melting glaciers and they think, oh no, glaciers are melting, we're in big trouble.
I think many people would fail to recognize the significance of the loss of glaciers in the Wind Rivers.
Why are these glaciers melting? How are they melting? What's the cause of it?
If the glaciers leave, we can't survive. Water is key in farming and ranching.
Irrigation is just as important. Municipal water is just as important. Livestock water is important. All these other things are just as important.
If we have reduced stream flow, it can definitely affect our trout populations.
How does that impact the wildlife? How does it impact the vegetation?
They are absolutely fascinating. They're incredible to look at. I'm always in awe in that size and that power when you stand in front of a glacier and you see how massive it is.
Major funding for Glaciers of the Winds was provided in part by a grant from Wyoming Humanities, expanding the Wyoming narrative to promote engaged communities. Additional funding provided by Wind River Outdoor Company, proudly serving Wyoming with outdoor supplies, camping gear, and guided fishing since 2010. Located on the web at windriveroutdoorcompany.com. Glaciers are on every continent except Australia. They cover nearly 10% of the Earth's land surface and provide nearly 3/4 of the world's fresh water. For millennia, glaciers have carved valleys and eroded and scoured the landscape. Continental glaciers, or ice sheets, cover nearly all of Greenland and Antarctica.
Mountain glaciers, specifically around the world, serve over 1 billion people in terms of their water resource. The Alps, the Andes, they have glaciers as well, right on the equator, that are incredibly important to their communities.
But huge glaciers in polar regions are disappearing at an alarming rate. A mass of ice the size of Delaware recently broke away from Antarctica. And Greenland's glaciers regularly calve huge icebergs into the North Atlantic. As a result, sea levels are rising in low-lying areas around the world. And while interior mountain glaciers are not nearly as large as those near the poles, their cumulative melting could potentially raise sea levels even more quickly. Alpine glaciers are found only in steep-walled mountain basins and U-shaped valleys, like those in the Wind River Range. The Wind Rivers slash across 120 miles of west-central Wyoming. They're home to more than 40 named peaks over 13,000 feet, and 7 of the largest glaciers in the American Rockies. Glaciers represent a unique source of fresh water for cities, farms, ranches, factories, fish and wildlife, and are important components of an area's recreation opportunities and tourism. But in Wyoming, as in the rest of the world, melting glaciers pose a threat to communities and ecosystems.
We'll follow the trail around Burro Flats on this east side. We top out at 10,008, and we're starting out down here at about 76. So you do the math.
A group of citizen scientists are heading deep into the Wind River Range towards Gannett Peak, the highest point in the state. At 13,804 feet, it is considered to be one of the country's most difficult points to summit. Gannett is in the midst of steep, rugged, and remote wilderness. Tucked away on its northern and eastern slopes lie two of the largest ice masses in the American Rockies, Gannett and Dinwoody Glaciers. The glaciers of the winds have been shrinking at an accelerated rate over the past 40 years. The impact from glacial retreat could have significant effects on the local ecosystem and downstream farms and ranches.
Use this to springboard yourself into other stuff.
Jackie Clancher, assistant professor of environmental health at Central Wyoming College, and her students are on a scientific expedition to understand the impact of melting glaciers. They call it the Interdisciplinary Climate Change Expedition, or ICE. Much of their work is done at the Dinwoody Cirque, a steep hollow filled with rock and ice at an altitude of 11,000 feet. Unpredictable weather is a constant challenge.
This is a logistically highly intense, highly complex expedition. There's no question about it. For us to bring them to an environment that's difficult to access, 20 miles in the backcountry, where the weather plays a significant role, then they work at elevation, and they work in an astounding physical environment where they're tired. And the challenges they face are some that they don't even anticipate. Working together in a big group, having them display leadership and tolerance for adversity and for challenging travel conditions that sets them up well to have to work together as a team.
Mountain man. We can kind of just mock map some stuff while we're sitting here so you guys can see what's in there.
We have combined geophysics, geographic information science, biology, geomorphology, and archaeology into one research expedition. It's intense, it's fascinating, it's all-consuming. It can be draining, but it's also exhilarating. We could bring it up, over.
First thing to start with is, how do you get a glacier? The snow falls and lands on the side of the mountains and it starts building up. If you look at the maps here in the Wind Rivers, most of the glaciers are on the east side because that's where a lot of that moisture is getting dropped, and it also gets less sun exposure. So if winter after winter more snow falls than melts in the summer, you're gonna have a bigger and bigger snow patch. Once that snow patch gets big enough and heavy enough, it's gonna compress itself into ice. And once there's enough ice, it'll have enough mass on top of it that it's gonna start to flow. I'm Sarah Conrad. I'm a glaciologist, and I'm up here on the Dinwoody Glacier in Wyoming. One of the reasons that I'm here is because I'm Deputy Director of Wyoming EPSCoR, which is the grant funding organization that's allowed this trip to take place. And Wyoming EPSCoR is an organization funded by the National Science Foundation to help us increase research infrastructure in the state. We're encouraging these community college students before they come to the University of Wyoming to get a little research under their belts. So we're in the middle of August right now. We're getting pretty close to the end of the melt season. If you look up at the very top, you can see snow, white snow. And if you look at the bottom, it's gray, and that's exposed ice. It's called the firn line. So the firn line moves up, and it's the balance between accumulation and ablation. Ablation means melting. What glaciologists do is they look at where that line is over the years on a glacier. If that line's moving up, the glacier is becoming smaller and receding. If the line's moving down, the glacier is gaining mass. All the glaciers in the winds, every year that line's getting a little higher up and a little higher up. So the first time I came into this area was actually in 1983. It was really interesting for me to come in again this year, 30 years later, And to see the changes in the glaciers, what I remember from then was in 1983, I climbed the north face of Gannett Peak, and the climb was a snow climb. And it was snow from the Gannett Glacier, going up across the Bergschrund, up a couloir, up to the very summit. We never got on rock. And this year, walking in and looking at the mountain as we came in, there was at least a stretch above the Gannett Glacier of probably 300 feet of rock. So really significant change in the size of the glaciers.
The Wind River Range is an important contributor to Wyoming's status as a headwaters state. The Continental Divide, which runs along the spine of the winds, determines which direction water will flow. Melting snow and glacial melt on the eastern slopes empty into the Wind River, which flows into the Missouri River Basin, and then on to the Gulf of Mexico. Waters from the western slopes drain into the Green and Colorado rivers, and on to the Pacific Ocean.
This is the Greater Yellowstone ecosystem, and of course there's all kinds of plants and animals that exist up here, and they need that water to survive. My name is Jeff Van Looy. I am an associate professor in the Department of Earth System Science and Policy at the University of North Dakota. I've always been interested in sort of these extreme environments. The first time I got to stand on a glacier was when we actually took a family trip up to Alaska when I was in high school. And I started to really sort of fall in love with them because they're so incredible. I mean, this huge mass of ice that's sitting there on the landscape. They're incredible to look at. They're gorgeous. I'm always in awe in that size and that power when you stand in front of a glacier and you see how massive it is. We've been doing research in the Wind River Range since about 2011 and have done GPS surveys to get elevations of the glacier, as well as stream flow measurements from water that's actually coming off the glacier. Also ice penetrating radar to understand how much volume is left in the glacier. These glaciers here in the Wind River Range are alpine glaciers. They are definitely smaller than a lot of glaciers, but it doesn't diminish their importance, again, as a water resource. And it doesn't diminish their importance in terms of the science, looking at why are these glaciers melting, how are they melting, what's the cause of it. They are definitely a barometer to climatic conditions.
The ice ages that totally mantled the Rocky Mountains with ice. And the big ice advance that went all the way down and formed these valleys was over 10,000 years ago. Well, the Dinwiddie Glacier that we're sitting on right now would have been maybe 30 miles long, as opposed to a half mile that it is now. The way that glaciologists and glacial geologists are able to tell when advances happen is because the glacier will flow down the mountain, and when it gets to its furthest point, it'll leave a pile of debris, which is known as the moraine. If a glacier advances to a certain point, leaves a moraine, and then later advances to a further point, that first moraine is wiped out and there's no longer any record of it. It's like a glacier essentially putting down roots and grabbing up big pieces of rock, which it then carries with it down the valley and leaves in the moraine. So it's really easy to tell where glaciers have been because of the U-shaped valley and also by the piles of debris that they leave behind. We are right on the terminal moraine of this glacier. This is a terminal moraine of the Little Ice Age advance.
One thing that happened from about 1400 to 1900 AD was this period, this cool period called the Little Ice Age. The glaciers actually would have been almost double the size as to what they are today.
The Little Ice Age, I always like to say, is a bit of a misnomer because when modern people hear the word Ice Age, they think woolly mammoths and saber-toothed tigers and ice everywhere. And the Little Ice Age is so called because it was really the most recent cooling period that happened in historical time. And
scientists are not necessarily conclusive as to how or why the Little Ice Age occurred. Nonetheless, at that time, these glaciers advanced.
So it was significant, and it was the last real advance that's recorded in the moraine history. But compared to the real big ice ages where the Earth was significantly colder, it was just a little blip. Glaciers are big masses of ice that are carrying all sorts of load, bits of rock, and as those rock come down and are moved by the glacier like sandpaper, sanding away and polishing, you end up, after the glacier comes through, this classic U-shaped valley where so much has been taken out of the bottom of the valley as opposed to the sides. So it really opens up a valley compared to what a stream would do. When the glacier comes through, it does all this eroding, some really big chunks of boulders, even little silt-sized bits of sand, which is what makes the stream so milky colored, and that's called glacial silt or glacial milk. The sand that's left in the valley gets picked up over the years by winds. It hits the corner here at the end of the valley, and in the process of hitting that corner, the wind slows down. It does not have the same energy that it had, and the sand is deposited right here at the corner. We're standing right now on these sand dunes that are on the side of the valley and go up against the mountain on the edge of the valley. Well, we were joking about camping here on a beach, and it's something that's not so often seen in an alpine environment.
As far as the actual glaciers in the Wind River Range, they're pretty sizable for being glaciers this far south latitudinally. They're up around 12,000, 13,000 feet in elevation, so those higher elevations help to keep things cool, helps to keep them around. The Beartooths up north of Yellowstone, the Teton Range, the Absarokas, they all have glaciers as well. There's more glacial mass in the greater Yellowstone ecosystem than anywhere else within the Rocky Mountains of the United States. Glaciers, generally speaking, are often found in pretty remote areas, and they can be extremely difficult to get to. The ones here in the Wind River Range are deep in the wilderness, far from any roads. The Wilderness Act, which was created in 1964, is very important, at least in my mind, as far as protection of these wild lands.
The Wilderness Act protects pristine areas within national forests by prohibiting motorized vehicles, mechanized activities, roads, permanent structures, mining and drilling. Most of the 728,000 acres of the Wind River Range is designated wilderness, encompassing the Bridger, Fitzpatrick, and Poposho wilderness areas. Visitors are encouraged to follow the 7 principles of Leave No Trace, including leave what you find, respect wildlife, and properly dispose of waste.
These glaciers here are kind of out of sight, out of mind. They're so deep in the wilderness that I think a lot of people don't realize they're there.
You know, you could be across from there, but we're also really tight, and the trail's coming around here with something, you know, blocky up there. So we're somewhere within this stretch here, is what we think. We are well away from any front country services for emergency care, for instance. Getting back here with moderately heavy packs, around 40 to 60 pounds, requires an allocation of at least 2.5 days of steady travel. It's an adventure all and of itself just to get back here.
We can't just fly in whenever we want or take an ATV or some other motorized vehicle and just jump off and be right at the glacier. You actually have to make the hard trek to get all the equipment in on horseback and on foot to be able to do the research.
Simply to get permitting access to work in a designated wilderness area is still a reasonably daunting written proposal.
Many of the Wind River's glaciers are more than a mile across and hundreds of feet thick.
A lot of people might think, well, you know, that's not very big, that doesn't sound very substantial. When you actually stand on a glacier, that's a lot of water sitting beneath you.
For perspective, one of the smallest glaciers, Knife Point, is about 200 feet deep.
That's almost a 20-story building. That's a lot of ice.
Continental Glacier, on the other hand, has been measured at nearly 600 feet thick. but it is apparently melting at a rate of a foot per year. So more than 50 feet of ice has been lost over the last half-century. The glacier still holds over 94 million cubic yards of ice.
If you were to take all of that ice and melt it out, it would basically cover over 52,000 acres in 1 foot of water. So that's a pretty substantial amount of water to actually melt out and to be able to use in the future, as a resource. And that's just off of one glacier within this range.
Glaciers of the winds can account for as much as 30 to 40% of the late summer stream flow in the Green and Wind River watersheds. A significant amount of late summer water is important to the high desert communities downstream.
The Dinwiddie Glacier itself is a water resource for Wyoming, for ranchers, for municipal and agricultural use. So once it's gone, especially during the summer, I assume there will be a pretty noticeable loss in the summer stream flow.
Annual snowpack in the winds and rainfall on the Wind River Reservation has been dropping since the turn of the 21st century, driven by warming temperatures. Increasingly frequent water shortages and droughts on the reservation are threatening its farmers, ranchers, and others who depend on snowmelt and rainfall for their livelihoods. Disappearing glaciers make these threats even more serious.
The glaciers up above Bull Lake, they're disappearing, and they're disappearing fast. There's 26,000 acres irrigated lands on the reservation. My name is Richard Baldus. I'm a current member of the Tribal Water Board. We control the water through the Tribal Water Engineer's Office for everything, whether it's fish, wildlife, or irrigation. One is just as important as the other. Those late season waters that farmers depend on and others depend on are not going to be available. They're going to be gone.
Because of the remoteness of these glaciers and because people don't necessarily associate turning on the tap with climate change, with glaciers, many people would fail to recognize the significance of the loss of all of the glaciers in the Wind Rivers, which are exhibiting the same pattern of recession.
In the winter of 2017, there was actually a substantial snowpack that fell up in the Wind River Range and throughout the Greater Yellowstone ecosystem. It doesn't necessarily mean that these glaciers are on the rebound. In 2011, we also had a really healthy snowpack up in the mountains. If we look at the years in between, 2012 to 2016, those were all pretty darn dry years. We saw quite a bit of melting going on then. So even if you have a couple of years where there's a large snowpack, it's all those other hot, dry years in between that are going to make the difference overall in whether or not the glacier is going to be able to hang around. And you need that snowfall to build the glacier. That's one contributing factor. But also the low temperatures are actually going up. And that's one of the contributing factors to these glaciers melting away. Glaciers react differently in different locations given their conditions, but nonetheless, we're seeing the same thing worldwide. This fits right along with what's happening elsewhere.
Today really is the culmination of a couple of years of effort in remeasuring the depth of the Dinwiddie. So that's pretty exciting.
Darren Wells is one of the professors with the ICE expedition and is head of the GPR team.
Last year, as you guys know, we had a different antenna and it just didn't quite give us enough depth to get good readings on the glaciers.
We were using a GPR, which stands for ground penetrating radar. Basically what we were trying to do is find the volume of the glacier. So we were dragging the antenna across the glacier on a specific transect, hoping to hit bedrock and tell how deep the ice is. But due to some datum shift, we were 200 meters off.
I mean, this is what it looks like. I mean, we can adjust.
You're not collecting data.
See, it's weird because we adjust it.
Jackie Clancher had contacted my advisor, Jeff Van Looy. She wanted to use his ice penetrating radar, which would reach all the way to bedrock in this glacier. My name is Lance DeAngelis. I'm with the University of North Dakota. My field of study is Earth System Sciences, specifically glaciology. CWC had run previous transects of the Dinwiddie Glacier, and over one of the sections we're unable to reach bedrock.
I'm hoping we'll be able to remeasure the Dinwiddie Glacier along a transect line around 11,600 feet.
What we're trying to do is see how far these glaciers are receding, how far they're melting. We see recession since the Little Ice Age. There's been many documented papers on it.
The first scientific observation of glaciers in the winds was done in 1931 and followed up in 1950 by Mark F. Meyer, who mapped and recorded measurements of 14 of the largest glaciers. Meyer reported the glaciers were growing. But later papers in the 1950s, 60s, and 70s showed the glaciers were shrinking.
What we'd like to do is create a new benchmark for the greater Yellowstone ecosystem. There was a study conducted in 2006 by Cheeseborough where he had run 2 transects across the ice.
Let's rerun the Cheeseborough transect with both antennae. We'll use the 100 megahertz antenna today, and then tomorrow.
Now we can compare these measurements and really get a sense of how far the glacier has melted in terms of depth. The ice-penetrating radar bounces a signal off the bedrock into the surface of the ice, giving you a profile of depth along various transects of the ice.
We're creating a baseline, but we're also building off of previous research in hopes to be able to come up with an accurate figure of when this glacier might disappear completely.
When we were doing our field test, there are some significant sections of the glacier that are now, for the first time, below that 30-meter depth. Hard to imagine that they were able to get something over this even in 2006.
Without doing these studies on the ground, we can't really determine exactly what the glacier's volume is.
I suspect since the 2006 transect, we're going to see a pretty big difference in volume.
We're going to rephoto the upper Dinwiddie from a couple of different angles, and that will allow us to compare these photos with photos from 2006, photos from the 80s, and all the way back to the 30s.
Just looking at the photos of the glacier, the changes are just dramatic, so I think we're going to see a big drop in volume.
Glacial melt affects water quality as well as quantity in headwater streams.
As the ice recedes and exposes more bedrock, what does that tell us?
Could be stuff coming out of the ice, melting into the water, changing the pH.
Yeah, we might be exposing more variety in the geological substrate, and it might be changing the pH.
We're curious whether that will change water quality in any way, and made an assessment of the quality of the water coming off the glacier. Water quality in a headwater stream at the base of a glacier in a wilderness area should be excellent. And all indicators suggested that.
Jackie Clancher and I hiked up to the Dinwiddie Cert to collect water samples because it's such a highly impacted area by climbers and hikers alike. Their waste management ideas are not always correct, and so we wanted to take water samples and see if there was harmful E. coli in it.
Is there more presence of E. coli in heavily used areas versus less impacted areas where there may be either less E. coli or none? We're going to put a little E. coli into this tube. It will change the pH of this broth and turn it to yellow, and we'll know that it's a positive sample. So the magic of this, having this incubator here and field collecting up here, is that we can actually get the process of analysis started. Because we are about 21 miles from the roadhead, there is no physical way we could get this to the lab within 4 to 6 hours. So we essentially brought the lab to us so we could start analysis of our samples via incubation.
Oh, 103 degrees.
Sweet.
Yes.
All right. This incubator's freaking cool.
Yeah, it is really cool.
All right. Backcountry science.
There has been debate as to, well, what's causing it? Is it humans? Is it the greenhouse gases? Is it natural cycles? From 1900 out of the Little Ice Age, you're compounding it with increases in human activity in the greenhouse gases. And so it is a bit of a combination, but anything from this point on is going to be more likely related to the human-induced changes.
The truth is, glaciers always melt. And essentially what's causing it to melt is the heat, the infrared radiation from the sun hitting it. And in many cases, since the ice and the snow is really white, it doesn't absorb heat that much. But little particulate matter, little rocks, small rocks, dust, actually really increases the melting because it so much darkens the snow that it can absorb more infrared heat as opposed to reflecting it.
If you look around here, you see this dark rock and you see all these dark, dirty spots. They absorb the UV radiation and they heat up faster than the reflective snow and ice, and they melt out the snow and ice faster. So essentially, black carbon can be viewed like that rock there that's melting a hole in the snow we're standing on right now, but we just can't see how it's melting it. So we're trying to get down to the whitest looking snow that we can find. Black carbon is believed to be a part of the incomplete combustion of the burning of fossil fuels, wildfires, or man-made fires. It's also believed to be found in the byproducts of industries like the oil and gas industry and any kind of plants or warehouses that are exhausting pollution into the atmosphere. It gets into the air and it travels via the weather systems, and once it gets down on the snow and the ice, it increases the melt rate of it. After we collect all these bags of snow and these samples, we take them back on site and keep the samples as fresh and intact as possible.
That'll be number 5. We're taking all our samples we've collected the past 2 days. We're melting the samples to put in these syringes so we can push the water through these nanopore filters and collect the black carbon particulates.
And those filters are what we collect and log our data off of.
These samples we took today are going to be sent off to University of Wyoming to have their isotopes analyzed to find the true source of the black carbon.
Last year, we actually found traces of black carbon in all 17 samples we took on the glacier. And no one had done black carbon sampling up on glaciers in the lower 48 states. Nothing at this altitude or this remote of an area.
This is original research that has not been performed in the winds. Black carbon sampling provided results not entirely different from other snow samples throughout the nation, but of significance for a remote wilderness area. There are some land use changes that you can make and human activity changes that can reduce black carbon deposition. We're eager to continue to sample throughout the winds.
While black carbon deposits hasten glacial melting, temperature increases also play a large role in increasing melt rates.
What we're seeing is the temperature causing higher melt rates. Even though this year was a larger than average snowpack, we had very high temperatures that had melted a lot of that snowpack away.
We're trying to see how the change in both temperature and how climate change is affecting the flow of the water, the quality of the water. We know that the water is going to be lower, slower in the morning, and I hopped in the water with the flow meter, and I was measuring depth and velocity of the water going from one side of the stream to the other. As the day goes on, the sun gets higher, gets warmer. It's warming things up on the glaciers, and more water is rushing down and coming through this moraine behind me here, going through the rocks and coming out. So in the morning, it's going to decrease again as it gets colder.
From previous studies, we can get an average melt rate per year. As these melt rates continue to fluctuate, it affects downstream communities.
One other way a glacier might melt is rainfall. So if you get a summer rainstorm or a thunderstorm, the water that hits is warmer than freezing, and so it brings heat to the glacier and it melts on impact, and as it percolates down through the glacier, it also carries that heat energy with it, and as it cools, it melts some of the glacier ice as well. All of those natural processes that we've talked about can be exacerbated by climate change. The increase of greenhouse gases is going to increase global temperatures, which is going to cause the mass balance of glaciers to change, and they're going to lose mass, and they're going to recede, and they're going to melt.
Each year as that glacier recedes, we're curious whether that will change actual water body temperatures over time. If there was no glacier feeding the surface water, the temperature would be remarkably different.
The fish that rely on a certain temperature, as well as a certain amount of water in the streams, may end up disappearing as those glaciers go away. Those fish going away may have an impact on other aquatic species.
The health and productivity of the wind's cold water trout streams and lakes depend on macroinvertebrates, insects like mayflies, caddisflies, and stoneflies, important food for trout.
The water that comes onto the reservation for irrigation is primarily from the Little Wind River. Most of the water in the Little Wind system comes from Wasky Reservoir, fed by smaller glaciers. I'm former project leader for the Lander Field Office for the U.S. Fish and Wildlife Service. And our main responsibility was fish and wildlife management on the reservation, working with both the Shoshone and Arapaho tribes. Some of the best fishing in the country is right here on this reservation. One of the reasons that Chief Wasky and the tribes picked this area was because of cold, clear streams with lots of fish and lots of wildlife.
When we have low water years, there's not much water left in the river because most of it is diverted for irrigation. Dewatering in general can have a lot of effects on fish populations. It can raise water temperatures, which can affect larval fish development and possibly even kill fish eggs.
18.7, yeah.
We are taking fin clips on these saugers because we want to evaluate genetic purity.
Sauger are definitely native species to the drainage, and if we don't have a healthy sauger population, that's definitely kind of a red flag that the ecosystem's not doing great either. Sauger have been evolving in this drainage since glaciers started to recede about 10,000 years ago. You know, of course, the environment changes as the glaciers recede.
When the glaciers disappear, and they are disappearing, there's less flowing in the rivers and systems, but especially during a drought year and late in the season. That will kill fish, that will kill invertebrates.
Reduced stream flow in our river systems, particularly at higher elevations that trout inhabit, can definitely affect our trout populations and other native fish. If we have receding glaciers and it leads to lower stream flow, it can lead to increased water temperatures that are not ideal for a cold water fish like trout.
Trout have to have cold, clear streams. They're cold water species. If it gets up to around 70, especially a little bit above 70, they die. It's as simple as that.
Less snow and rainfall and shrinking glaciers can increase the temperatures in these fisheries, impacting macroinvertebrate populations and imperiling trout and species like frogs and birds that prey on these insects.
These are still some of the biggest glaciers in the lower 48, so they're still really significant and they still hold a lot of water in them. It's really important because glaciers in alpine environments like this are like the freezer that you have in your garage for preserving things. They're the freezer of water, and they preserve water for summer use. You know, we're not a super highly populated state, but we do have a lot of agriculture and are very dependent on water and irrigation. Not only is it just for Wyoming, but we're the headwaters for many of the western states.
During the dry years when there's a relatively low snowpack, glaciers are potentially contributing as much as 45% to the creeks, to the basins in which flow into the Wind River. It's pretty substantial and important to agriculture in this area.
Because none of us can predict the weather or know how much of a drought we're going to get at any time, our goal every irrigation season is to fill these reservoirs in preparation for the irrigation season. And the amount of water available to us is the biggest factor, of course, in making that happen. My name's John Howell. I'm the manager of Midvale Irrigation District. Midvale Irrigation District is the largest irrigation district in the state. The sole purpose of diversion dam is, as the name implies, is to divert water from the Wind River into Wyoming Canal, which is the source of all of our irrigation water. We have two storage reservoirs in the district, Bull Lake Reservoir and Pilot Butte Reservoir. That's our goal, is to fill those reservoirs. Having said that, they have a finite capacity. They can only hold so much water safely.
When you think about the floods that come in May and June, a lot of that water is not captured by smaller dams and reservoirs that we have because they're simply not big enough to catch it all. It's almost too much water at once, too much of a good thing. Water is kind of the liquid gold of the West. If there's 1 month of a deluge and you just can't store it and you can't put it all away, well then it's gone and it's lost to you forever. That water in May or in June, that's all coming from runoff. And that water is relatively cheap, if you want to put a value on it, compared to the water that you're getting in July and August.
There's been times the 1st of August, this time of year, there was no water in the system to irrigate. Well, after you hay, you need to irrigate the ground. In some years, we were not able to do that. And when you have the shortages of water, the glaciers disappearing, and droughts like we've had the last, quite a few years, you have to have storage. And we are short of storage, especially on the reservation.
Drought periods have a significant impact on our irrigation district. It's all about available water. And the water that we have available is the water that's in the river and the water that is in our storage reservoirs.
That water you're getting in July and August, a significant portion is coming from glacier ice. Instead of having a dam, you got a glacier. So really, having glaciers keeps us from building more dams. If we lost the glaciers, we'd probably have to build more dams to be able to have that constant supply of water.
Oh, they're incredibly expensive and highly regulated. My guess is just about any district would like another reservoir.
Unfortunately, sometimes reservoirs are, you could look at them as being a bad thing. A reservoir to be built today, depending on the size, of course, would be probably over $100 million. Who knows? Maybe more. If they're being built on a river system, well, that could be detrimental to fisheries. As a biologist, that can be. In-stream flow is a flow of water that is designated by biologists to provide enough water for life in the river. Diversion dam is probably the worst thing that ever happened to the Wind River, because most of the water is diverted into Wyoming Canal. It blocks fish passage for upstream movement.
Expanding capacity of off-stream storage is a promising approach to reducing in-stream flow-related impact on fish habitat. Tanks or reservoirs can be filled in the wet season when water is abundant and used for irrigation and other needs during droughts.
On this reservation, there's been all kinds of sites for 25 to 30 years, and it's been continuing to this day, yet not one's been built.
Even though we've got pretty good climate models from the climate scientists, it's hard to say for sure exactly how long a glacier is going to be around. The estimate for continental glacier is that it may be around for another 130 years or so. That's really not that long if you really think about it. What do we need to do with our crops? How do we change our water use habits? What does that mean for the future generations, for the future farmers that are going to be living in these valleys?
I was born and raised on the Wind River Reservation. My grandpa homesteaded out there in '42, and then my dad took over and my two other brothers still farm out there. My name is Scott Fegler. I live here in Shoshone, Wyoming, and this is the farm I mainly raise alfalfa and malt barley and red beans.
Agriculture, and its often heavy use of irrigation, is one of the largest consumers of fresh water in the United States. Water is used for irrigating crops, but it is also needed for livestock. In addition, water is needed for the crops that are fed to the livestock. The cumulative effect is significant.
The alfalfa is mainly for livestock. Most of my alfalfa gets shipped out of state. And the red beans get shipped to Greeley, Colorado, and then processed and packaged and shipped all over the world. Most of everything is flood irrigated, so all of the canals and lateral systems that Midvale put in are all designed to pretty much flood every acre that they could get under. When I was flood irrigating it, I would never turn the water off. It was nonstop water. You're putting at least 3 inches of water on the ground. For this pivot, I can water 230 acres in 3 days, and everything is covered evenly. And then as soon as it dries up a little bit, I can turn it back on and in 3 days cover it again. There's no waste, there's no runoff. I mean, we're just watering the crops. They are, I would say, around 90% efficient. Late season water is very key for us, for them glaciers to, stay formed in the mountains. And that's where we like to see the snow. It's the most important part of irrigation. Everything on this side of the Continental Divide that runs towards the Wind River, it's coming here.
Glacier water is one of many contributors to the water that's in the river. We had a high snowpack year and a lot of precipitation, probably wouldn't matter. But on a very severe drought year, it might have more of an impact. In a typical drought situation, the storage water is extremely important because that's usually even a higher percentage of the water that would be available to us, since the river is running usually much lower than normal in a drought period.
We're watering right up till the middle of September. The alfalfa, that's probably one of the biggest crops that need the latest irrigation. Going into the winter, if your alfalfa crop is, dry and you haven't watered it, you're gonna have a lot of winter kill and your stand is not gonna last. Sugar beets, they're just like alfalfa. They need the late season irrigation to finish making the beet. You have to have moisture to pull them out of the ground too. All the late season irrigation is crucial. The livestock still need water, and if you don't have water where your pasture is, you have to run, irrigation water down to them so they have something to drink. If we didn't have glaciers, we need reservoirs, we need storage. If the glaciers leave and we run out of water, I will have to either go somewhere where there is water and farming or, learn to live without it. But I really can't see that happening. I don't want it to happen, let's put it that way.
Are the farmers and the ranchers down the line, are they going to be saying the same thing? I hope so. I really hope that they're still able to survive with the possible loss of water that may happen. Glaciers are not just a source of water for irrigation or even for the ecosystem as a whole. It's also municipal drinking water. When these glaciers melt away, things are going to have to change for these communities. That's really my concern, is what are the future generations really going to be thinking? And how did we manage things? How did we take care of things? I think what it really comes down to is adaptation. We're all really going to just need to adapt to the changes that we're going to have to face in the future. And if we start now, it'll make things a lot easier. It's hard to think about sometimes. And it's hard to solve the problem too. There's no easy answer.
Glacier runoff gives life not only to agriculture, but also to the plants and animals in the region.
As you see right below the glacier that we're sitting on, there's very little alive. It's really recently uncovered from ice. And as you proceed down valley, you get more and more stuff growing as soils have set in since glaciation. In the last 10,000 years, The whole forest system in this glaciated valley below us has developed. And it has developed that whole 10,000 years with this water source up above it. So if this water source were to disappear, it's certainly going to change because it grew up under these conditions.
One of the concerns with the GYE is ecosystem management. What is going to happen to the plants and the animals as the water goes away? How does the management adapt to these changes in stream flow if the glaciers disappear?
These alpine systems, they're very extreme, and many of the plants and animals have special adaptations to deal with that extreme environment. Bighorn sheep certainly are the primary big game species that people think of when they think of these alpine systems. We also have elk and mule deer. My name is Greg Anderson. I'm a wildlife biologist with the Wyoming Game and Fish Department. As grasses cure out lower, these animals like to feed on lush green new vegetation that helps with their energy production for lactation. You see bighorn sheep and elk migrating up to higher elevations in the summertime to take advantage of the lush green vegetation that's there. If those glaciers were to disappear, we'd be looking at likely a more arid environment. In a place like the Wind Rivers where we've got perennial streams, we might begin talking about ephemeral streams that would flow for early through midsummer and then might dry up or certainly have less water flowing towards the end of summer. That would impact the amount of feed available for big game species, nesting habitat for birds. One of our main tasks is to provide recreational hunting for folks in the state. Non-residents come in and take advantage of hunting that brings in a lot of revenue to the state and to the game and fish, upwards of $13 million in a county like Fremont County. There are potential big impacts as game species are impacted by something like changes in these alpine systems.
As soon as you remove something, which was what originally allowed it to grow and to create, it's going to have to adapt. And whether different species will move in that can tolerate a less consistent water regime, or whether that means it's going to just dry out, be much more prone to wildfire, and large species animals will no longer be able to live because there won't be as much cover and protection.
We adapt our management to how things change on the ground. Obviously, the Wyoming Game and Fish Department isn't going to have an impact on glacial presence or glacial melt. But you know, if we see significant impacts over the decades due to some loss of glacial melt, our habitat biologists will have to make changes in their programs and account for that in changing habitat. If the glaciers were to disappear, it would decrease the amount of alpine tundra areas available for certain animals. We're responsible for non-game and game species in the state. We've got a number of non-game species that rely on high alpine systems throughout their life cycles. Pikas are one that live their entire lives in the high mountains above tree line. There are several bird species that are reliant on alpine tundra. One of the main ones are rosy finches who nest and spend their summers up in the highest elevation portions of Wyoming, up near Gannett Peak.
With these streams potentially drying up altogether, depending on where they are, the plants that are in those riparian zones next to the streams are potentially going to change as well.
Without a doubt, it would change the complexion of the landscape.
It'll have a very large impact on these mountain ecosystems.
Water from the glaciers is critical for communities, farms, ranches, recreation, fish and wildlife. Less water threatens the way of life in central and western Wyoming.
There's natural variability in the climate. As you add gases to the atmosphere, heat-trapping greenhouse gases, you see an increase in the temperatures warming the Earth.
If you take out 20, 40, 60% to the stream flow, that's going to be very significant in those years in which there is very, very low snowpack.
I think the implications of that for land managers and users, agriculturalists as well, is really significant.
It's astounding to see like the difference between Dinwiddie and Gannett and the Gooseneck Glacier. They're all rapidly changing.
It's kind of interesting and brings into perspective how much water is needed for the irrigation process. Right here is where the water enters the system. But if you go all the way to the end of the Wyoming Canal, where it eventually dumps back into Boysen Reservoir, you could actually step across it. Every time I do that, it reminds me of really how much water is needed to irrigate those acres.
Just to see this loss of snow and ice is kind of, it's tough. And the fact that we're losing them due to climate change is really putting the onus on us and saying, look, if we can't change what we're doing, not only will this glacier be gone, but the glaciers of the world will be gone.
From a spiritual standpoint, I'm quoting Starweed. He said, water is the lifeblood of everything. Without water, there's nothing.
Major funding for Glaciers of the Winds was provided in part by a grant from Wyoming Humanities, expanding the Wyoming narrative to promote engaged communities. Additional funding provided by Wind River Outdoor Company, proudly serving Wyoming with outdoor supplies, camping gear, and guided fishing since 2010. Located on the web at windriveroutdoorcompany.com. And by the members of Wyoming PBS. Thank you for your support.
Glaciers of the Winds is available on DVD for $19.95 and on Blu-ray for $24.95. Order online at shop.wyomingpbs.org.